multiplying polynomials. So now we're going to look at how do we multiply polynomials together when they're both neither polynomial is a monomial. We'll start off with sort of the simplest case we could think of, actually. X plus 1 and x plus 2. Binomials, both of them. And the constant terms are, well, the numbers 1 and 2. The way it works is you need to choose one of the polynomials to distribute into. Then you assign the other polynomial, you treat the other polynomial sort of like a monomial. You distribute the entire thing into each term. So that's the main idea. Distribute entire left polynomial. You can always rearrange it because it's a multiplication. So we'll say distribute entire left side polynomial into each term of right side polynomial. Then that is going to look something like this. Let's rewrite. So x plus 1 times x plus 2. So this entire left side polynomial multiplies to x and then multiplies. And let me use different colors for each distribution here. Use green for the first one, blue for the second. So we have x plus 1 times x times x. Followed by plus, because of the plus right here. Let me put that plus in the color red to kind of signify how it's carried over from this polynomial to this new expression. And then the second distribution, we have x plus 1 times 2. Now it's okay to distribute things from the left. So we get x times x, x times 1. Similarly, in the second term, we have 2 times x and 2 times 1. So we get x times x plus 1 times x plus, in the second term, 2 times x plus 1 times 2. Which cleans up into x squared plus 1x is just x plus 2x. Well, let's combine these are like terms. 1x plus 2x is 3x. And then 1 times 2 is 2. That is our solution. 3x minus 6 times 2x minus 7 we have this entire 3x minus 6 multiplies to the 2x and multiplies to the negative 7. So we have, and if you'd like, you can arrange the 2x to the left of the 3x, which we'll do in this example. So 2x times the entire 3x minus 6, in case you like distributing from the left here, as opposed to distributing from the right, as I misspoke earlier. And then negative, well, 3x minus 6 times negative 7 is the same thing as negative 7 times 3x minus 6. So this 2x shows up here, and this negative 7 shows up here. Now we can do distributions here and here. So we get 2x times 3x, and then minus, write the operation first when it's a negative, when it's minus here, and it's positive here. So minus, and then 2x times the number. Here we have minus 7 times 3x, so minus 7 times 3x. And then lastly, negative 7 times negative 6. So minus 7 times negative 6. Multiplying through, we get 2 times 3, 6, x times x, x squared. Then minus 12x minus 21x. Then minus 7 times minus 6, positive 42. Then adding the like terms, we end up with 6x squared minus 33x plus 42. Let's go ahead and box that answer in. Last example here. Well, this example here, we have multiple terms in our polynomial, more than 2. So a binomial times a polynomial with 3 terms. The same idea holds. So we have x minus 2 times 3x squared minus 4x plus 5. So the x minus 2 distributes to the 3 terms in the second polynomial. And we get 3x squared times x minus 2. And then minus 4x times x minus 2. Then plus 5 times x minus 2. Now we have monomial times polynomials. Well, monomials times binomials. So distribute in. You get 3x squared times x minus 3x squared times 2. And then next terms, minus 4x times x. and minus 4x times negative 2. Notice how I'm encasing these constants in parentheses for the multiplications. Last term, distribute through 5x. 5 times x, 5x. And then 5 times negative 2. So it's positive 5, so do plus 5. And then times negative 2. All right, so we have 3 x squared times x is x cubed. Negative 3x squared times 2 is multiply the numbers. 3 times 2 is 6. So minus 6x squared. Next term, negative 4x squared. Next term, negative 4 times negative 2 is positive 8. So positive 8x. Plus 5x. And then 5 times negative 2, negative 10, so minus 10. Then simply combine like terms. We have two sets of like terms here and here. That gets us 3x cubed minus 10x squared plus 13x minus 10. Which is our answer. Here's kind of a challenge. Multiply and simplify. And we have a minus b times a plus b squared. Well, what does a plus b squared mean? It means the binomial a plus b times the same binomial a plus b. So we have a minus b times a plus b times a plus b. Now we could multiply these together first, or these together. We're going to multiply the first two together. So we have a minus b, the entire binomial, times the first two terms here. So a minus b times a plus doesn't matter if you multiply the outside polynomial to the left or the right of the terms of the polynomial you're distributing into. Doesn't matter. Most people might want to multiply to this side of the variables. Feels more natural. All right. So this a comes from here. This b is this b here. Okay. But this is critical. So we're multiplying something in to something that's in parentheses, which is then itself multiplied to something in parentheses. So it's crucial that these parentheses, I'll put them in red, that you maintain these parentheses. So everything we have here is inside the red parentheses now, multiplied to the a plus b polynomial itself in parentheses. Okay, I'm going to erase these lines here. Now go ahead and distribute in. And we have, again, keeping our red parentheses, we have a times a minus a times b plus b times a, we'll just call that a times b, minus, from here, b times b, and then times a plus b. Now notice we have like terms here. A times b, well, negative a times b plus a times b. So those cancel, and we have a squared minus b times b, b squared. So a squared minus b squared times a plus b. Now we have to distribute either this into here or this into here. It's up to you. So let's distribute from left to right. Distribute from here to here and to here. So we get a times a squared minus b squared. And then the operation here that we're distributing into is plus. So we need that plus there. And then a squared minus b squared times b. So we can write the b first times a squared minus b squared. It's up to you which side you write which factor when you do your distribution. Now we have to distribute again. So we get a times a squared minus a times b squared, and then plus, distributing here, a squared b minus b times b squared. A times a squared is a cubed. And then minus ab squared should go after the plus a squared b. So we have descending powers of a. So plus a squared b from here first. Then we'll do minus ab squared, and then no power of a here. B times b squared, b cubed, so minus b cubed. And that is the simplified product of a minus b times a plus b quantity squared. Okay, so multiply two functions together. So we're asked to find p of x times q of x. To do that, simply substitute in the expressions for p and for q. So for p, we have 2x squared plus x minus 1 times 3x minus 2. So make sure to encase everything in parentheses whenever you multiply functions together. Right. Well, we could rewrite this with the smaller polynomial on the left, which is customary. Using the commutative property, we rewrite 3x minus 2 first. So then times 2x squared plus x minus 1. Then distribute in. we have 3x times 2x squared plus, well, it's 3x minus 2 times 2x squared. So let me do 2x squared first. And then times 3x minus 2. And then x times 3x minus 2. And then minus 1 times 3x minus 2. Okay. So continuing, I rewrote it up here. So continuing, we distribute through with each term. 2x squared times 3x is 2 times 3, 6. X squared times x, x cubed. Then 2x squared times negative 2 is 2 times negative 2, negative 4. X squared, well, there's no other x, so no other power of x, so x squared. Next term, distribute in, and we get plus 3x squared minus 2x. Last term, distribute in, minus 1, negative 1 times 3x is negative 3x. Then negative 1 times negative 2, negative times negative positive, 1 times 2, 2. Lastly, combine like terms, and we get 6x cubed. Negative 4 plus 3, negative 1, so negative x squared. Negative 2x minus negative 3x is negative 2 minus 3, negative 5. And then, so negative 5x and then plus 2. So that is our answer. That is p of x times q of x. All right, so here's a doozy. Let's rewrite it over here. X squared plus 5x plus 2 times 2x squared minus 3x plus 4. Well, we want to distribute this entire polynomial to each term in the second polynomial. So we get 2x squared times x squared plus 5x plus 2. And then minus 3x times x squared plus 5x plus 2. And then plus 4 times x squared plus 5x plus 2. So distribute through each term. 2x squared times x squared is 2x to the 4th. 2x squared times 5x is 10x cubed. 2x squared times 2, 4x squared. Here we have negative 3x times x squared, so minus 3x cubed. Negative 3x times 5x, minus 15x. Negative 3x plus 2, minus 6x. Last term, distributing through, 4 times x squared plus 4x squared. 4 times 5x plus 20x. 4 times 2 plus 8. And then go through, collect, and combine like terms. So 10x cubed, negative 3x cubed, 4x squared, and a 4x squared. And then negative 15x, negative 6x, and positive 20x. So that's 2x to the fourth. For the x cubed terms, 10 minus 3 is positive 7, so plus 7x cubed. For the x squared terms, 4x squared plus 4x squared is 8x squared. And for the x squared terms, we have, and then for the x terms, negative 15 minus 6 is negative 21. And then plus 20. So negative 21 plus 20 is negative 1. We get minus x, and then plus 8.